All right, this is lessons 4.5 and 4.6 combined. It's the last lesson we're having on Unit 4 for Tuesday, January 28th. Let's start off with our bell ringer. All right, so these are a little bit of brain teasers. We're skipping this one because it's no longer Halloween. So what are the next three letters in the following sequence? You might have guessed that this is, these letters stand for the months of the year: January, February, March, April, May, June, July, August. So what comes next? September, October, November. So that's what goes in the blanks. And then this one, if it were 2 hours later, it would be half as long until midnight as it would be if it were an hour later. What time is it now? That one, the answer is, it is, I believe the answer is 9 o'clock p.m. because if it's 2 hours later, then it's 11 p.m. It's an hour to midnight. And if it's an hour later, it's 10 p.m., 2 hours to midnight. So if it's 2 hours later, it's only an hour, which is half as long as 2 hours later, 2 hours, which it will be at 10 o'clock. So 9 o'clock p.m., I think is the answer to that one. Just some little brain teasers. Okay. So today we are going to use the triangle inequality theorem. So we're going to start out by measuring these sides, and again, I have done that for you. So it says we're going to write some inequalities. We're going to add the two sides together and then write an inequality about how it relates to the third side. So something that looks like this. So if you want to check that to make sure that these would be true, 9 plus 8 is 17, which is greater than 5. That's true. 9 plus 5 is 14, which is greater than 8. That's true. And 8 plus 5 is 13, which is greater than 9. All of these inequalities are true. So try to think if this represents what the triangle inequality theorem is. If this set of inequalities represents what the triangle inequality theorem is, what would that be in your own words? Pause the video and try to write it out. So the best way I can think to put it is that the sum of any two sides of a triangle must be greater than the measure of the third side. So the sum of any two sides have to be greater than the third side. You can see if we add two sides together, they're bigger than the third side. Two sides together, bigger than the third side. Two sides together, bigger than the third side. Right? So the first exercise is, can you make a triangle from a side that's 3, a side that's 4, and a side that's 6? Well, 3 plus 4 is 7. 4 plus 6 is 10. 3 plus 6 is 9. 7 is greater than 6. 10 is greater than 3. 9 is greater than 4. That checks out. It fits the triangle inequality theorem. Yes, we could make a triangle out of those three sides. What about 4, 8, and 16? We set them all up again. We do our addition. However, 12 is not greater than 16. 4 plus 8 is not greater than 16. So we would not be able to make a triangle from those three sides. If I cut out strips, you'd be able to see that this was true. If I cut out a strip of paper that was 4 inches long, a strip of paper that was 8 inches long, and a strip of paper that was 18 inches long, 16 inches long, you'd be able to see that you would not be able to form a triangle out of those three pieces without having to like have a little bit of extra hangover or something like that, or ripping something off. Okay, so those are our first two exercises. Number 3 on the paper. We want to find the range of possible measures for the third side. So we have one side that's 1 centimeter and one side that's 6 centimeters. So how do we approach this? Well, first we go ahead and we set up those three inequalities, but we use x for our third side since we don't know what our x is. Well, we already know that this is going to be true. No matter what x is, 6 is already bigger than 1. Doesn't matter what we add to 6, this is already going to be true. So we can kind of leave that one alone. So we know that for this one, x has to be at least 6, because if we add 1 to 6, it will be greater than 6. 1 plus 6 is 7, 7 is greater than 6. All right? So the smallest x can be is 6. For finding the range, we have to find the smallest x can be and the biggest x can be. So this gives us the smallest x can be. And then if we look at this one down here, 1 plus 6 greater than x. 1 plus 6 is 7. So we know that for this to be true, 7 being greater than x, that x can't be any bigger than 6. So x has to be at least 6. It can't be smaller than 6 for this one to be true. And it can't be any bigger than 6 for this one to be true. So the only number that can work for x in this case, it has to be 6. Let's try it for 82 and 8. Pause, try it on your own, and then come back. So remember, 82 is already greater than 8, so it doesn't matter what x is, this one's already going to be true. We look at 8 plus x to find out what the smallest x can be to make this inequality true. X will have to be at least 75 to add to 8 to be bigger than 82. So x will have to be at least 75 to add to 8 to make 83. So x has to be at least 75. 82 plus 8 is 90. So x has to be smaller than 90, which means that x has to be no bigger than 89. So the third side of this triangle has to be between 75 and 89 meters. That's it for the first page of notes. Please go on to the next video for the second page.